Welcome back to DMS course. So here we look into the concept of combinations, which is in model 2. So I am Mrs. Archana Priyadarshini, assistant professor in the department of ISC, Canara Engineering College. So here in this particular video presentation, we look into what is combinations, some of the examples, and how do we generalize this combination concept using formulae. Together we will see certain problems related to this concept in detail. So in this slide, what you can see is nothing but the difference between permutations that you have already studied in the previous presentation along with the concept of combinations. So permutations just focuses on the order of the items or the arrangement of the items. So in this permutations you have got two variations, that is permutations with repetitions, and second variation is repetitions are not allowed. So if the repetition is allowed, for example, if there are n objects and it appears r times, so the number of possibility is n raised to r. And in the second variation is if the repetition is not allowed, how many such possibilities are possible? Yes, p of n comma r, which is nothing but n factorial by n minus r factorial, where n is the number of objects and r is the choice. That means out of n objects we are supposed to select r of them. Next, coming to combinations. In the combinations, the order doesn't matter. So again here we have got two variations. One is wherein repetition is allowed, the other where the repetition is not allowed. So if the repetition is allowed in combinations, so how many possibilities are possible? So if the repetition is allowed, the number of possibilities is NCR, which is nothing but n factorial by r factorial into n minus r factorial. So you can observe there is a change here wherein repetition is allowed. As you know, the combinations, any repetitions allowed is it's the same as NCR. It refers to one single combination. How many repetitions it may be? It refers to one single combination. It's nothing but NCR. So if the repetition is not allowed, how many such possibilities are possible? Is n plus r minus 1 whole factorial by r factorial into n minus 1 factorial. So let's see the difference between permutations and combinations. So in permutations, the order is important. In combinations, the order is not into consideration. So we'll see the difference based on the formulas. NPR can be written as n factorial by n minus r factorial, whereas NCR is n factorial versus r factorial into n minus r factorial. What you can see in permutations is nothing but the terms like arrangement, scheduling, or the order. Whereas in combinations, you just see a group or the collection or selection or sample of items. And we can also say the difference based on the definitions. Permutations is nothing but the arrangement. Combination is how we can select those subset of the items from the larger set. And both of them we have got two variations, that is repetitions are allowed and repetitions may not be allowed. What is combinations? Suppose we are interested to select a set of r objects from the set of n objects where r is obviously smaller than n. This set of r objects being selected is called combination of the r objects. And there is no importance given to the order. That is, if you say xyz is one combination, it is same as zyx. So R objects in the combination can be arranged in R factorial ways. But what you can see here is the formula of C of n comma R is nothing but you have got P of n comma R by R factorial. Just the arrangement of R different objects matters in combination. So we can see just the how does the combination of R objects, or how can R objects be arranged. So that's the difference here in C of n comma R. C of n comma R is n factorial by n minus R factorial, which is nothing but P of n comma R by R factorial. We have got R objects, they can be arranged in R factorial base. Take an example. So for the first example, how can we differentiate the examples with respect to permutations and combinations? The first example is picking a team of 3 people from a group of 10. How do we select 3 people? Any 3 people in random from a group of 10. So there is no such concept of ordering, or there is no arrangement in the given problem. Just the choice of selecting 3 people from a group of 10. So this comes under combination, which can be written as C of 10 comma 3. So out of 10 we are supposed to select a team of 3. So C of 10 comma 3 is 10 factorial by 7 factorial into 3 factorial. So which is 120. So next example is, suppose we have to select president, next vice president, and then what, a boy from a group of 10. So first of all, this is like an arrangement, or there is some ordering in which we have to select. First of all, we need to select the president, and after that the vice president, and so on. So there comes an ordering. So next here we'll see the number of ways in which a pair of objects can be selected from 5 distinguishable objects, such as the letters A, B, C, D, E. How many pairs of objects are possible from these 5 letters or 5 objects? So you can observe there are so many combinations, there are so many arrangements if we take here. A, B, B, A, A, C, C, A, B, C, C, B, B, D, D, B. Then we have got C, D, D, C, C, E, E, C, B, E, E, B, E, D, D, E, A, E, E, A, A, D, D, A. So all these 20 combinations, or 20 possible arrangements, we can say. It's not combinations at all, it is purely arrangement. We have to select 5 distinguishable objects. We have to select from these 5 distinguishable objects how many ways of pair of the objects are possible. So this comes under permutations. Let's see the first question. So let's look into the first problem here under combinations. So the question says you are supposed to find the committees of 5. How many committees of 5 with a particular chairperson can be selected from totally 12 persons? So we have got totally 12 persons, and we are supposed to form the committee of 5. In that, one is selected as a chairperson. So basically we can select a chairperson in 12 ways. And once this chairperson is already selected, from among the 11 persons, we are supposed to form and remaining 4 committees. So one committee is a chairperson committee. It is already selected, it can be selected in 12 ways. And the remaining 4 committees out of 11 remaining persons can be formed in C of 11, 4 ways, which are totally 12 into 330, which is 3960. The next question. At a certain college, the housing office has decided to appoint for each floor one male and one female residential advisor. We are supposed to find out different pairs of advisors which are possible for 7 floor buildings from this total set of 12 male and 15 female candidates. So, from these 12 male candidates, we can select 7 of them. That is, we are supposed to actually select 7 for 7 floor buildings, for 7 floors, for 7 different floors. So, from these 12 male candidates, 7 candidates can be selected in C of 12, 7 ways. And from the set of female candidates, that is from 15 female candidates, again 7 has to be selected, which can be done in C of 15, 7 ways. So totally the number of possible pairs of advisors which are possible to for a 7 floor building is C of 12, 7 into C of 15, 7 ways. So in the next question, a certain question paper is given and it contains 2 parts A and B, each containing 4 questions. So in each part we have got 4 questions, part A and in each part A and part B. And we're supposed to answer, the student is supposed to answer 5 questions. Okay, 5 questions by selecting at least 2 questions from each part. So in part A, I've got 4 questions. In part B, again, I've got 4 questions. And the totally the student has to answer 5 questions by selecting at least two from each part. Two has to be selected minimum. 2 questions have to be answered by the student minimum from each part, so that totally 5 questions are to be covered. How it can be done is either the choices. The 3 question can be selected from part A and 2 questions from part B. So, and 3 questions from part A, it can be done in C of 4, 3 ways. C of 4, 3 tells that we have got totally 4 questions in each part. Okay, let's consider part A now. 4 questions in each part. From part A, if we select 3 questions out of totally 4 questions, it can be done in C of 4, 3 ways. Into we are supposed to select again 2 more questions in order to select totally 5 questions. So in part B, once again there are totally 4 questions, and from these 4 questions we can select. We are supposed to select remaining 2 questions. So this can be done in C of 4, 2 ways. So totally, the first choice is C of 4, 3 into C of 4, 2 ways. This 24 ways. Now, this is first possibility. The other possibility is we can the student can select 2 questions from part A and 3 questions from part B, vice versa. Out of totally 4 questions in each part, and this can be done in C of 4, 2 into C of 4, 3, which is nothing but 24 ways. So the overall choice, so the total number of ways a student can answer 5 questions is add a sum rule. That is 24 plus 24, which is nothing but 48 ways. The next question: a woman has got 11 close relatives and she wishes to invite 5 of them to dinner. So totally there are 11 relatives, and the choice is to invite 5 of them to dinner. And but there are questions restrictions given here. In the first question is there is no restriction on the choice. That is, anybody can attend. There is no restriction. Anyone can attend. However, the she has to invite 5 of them, and this can be done out of 11 in C of 11, 5 ways, which is nothing but the answer to the first question. There is no restriction on the choice. So 5 out of 11 can be selected in C of 11, 5 ways. So coming to the second sub question, two particular persons will not attend separately. So what does this mean is persons, if they are going to attend, they are not going to attend separately, but they'll be attending together. That is the first possibility. The other possibility is if they are going to attend, they are coming together, or they might not be invited at all. So that is the second choice. So in the first choice, where 2 persons, if they are invited, they will attend together. Okay, this can be done in C of 9 comma 3 ways. So what does the C of 9 comma 3 ways tells is you're already selected two persons who will come together. So remaining three more out of five are to be invited. Okay, out of nine relatives, right? Two are already selected. Two are already selected for invitation. So that means I have to give the woman has to give invitations to remaining three more persons out of nine relatives. So that can be done in C of 9 comma 3 base. And this the C of 9 comma 3 refers to the choice wherein the woman invites those two persons, and those two persons are supposed to attend together. And the other possibility is the two persons are not being invited at all. Okay, the two persons are not invited. So however, the woman has to invite totally five of them, and this can be done in remaining. See, two is not selected, two are excluded from invitation, that is the second choice. So there are remaining nine persons totally, but the invitation has to be given to five of them. She has to invite five of them, and this can be done in C of 9 comma 5 ways. So totally we have C of 9 comma 3 plus C of 9 comma 5, which is nothing but 210. So coming to the third question, wherein two particular persons will not attend together. Okay, two particular persons will not attend together. That means the persons, if they are invited, they will attend separately. So, for example, if person P1 is invited, that means two persons are already invited, right? So they will once upon invitation they are going to attend separately. That is the meaning of the third question. They will not attend together, but they will attend separately once given the invitation. How will they attend separately is the invitation is already given to one person, so remaining four persons are to be invited out of nine. Okay, the invitation is given to both, but they have to attend separately. So it will be C of 9 comma 4 ways if we take particular person P1, and another person, let's say take P2, person P2 is also invited, but he has to attend separately. This can be done in C of 9 comma 4 ways. So C of 9 comma 4 tells that uh, two persons are invited, but the choice is to invite the remaining one person is already invited. It's like one person is already selected for invitation at a time. Okay, once given the invitation, so remaining four persons are to be selected out of five, right? So this can be done in C of 9 comma 4. So coming to the last in for the third option, answer to the third option, wherein we have got the last component, that is C of 9 comma 5. C of 9 comma 5 refers to the people wherein the invitation is not given. So what does the question actually say is two particular person will not attend together. That means if they are given the invitation, they are supposed to attend separately, and this can be done in C of 9 comma 4 ways. And if they are not being given the invitation at all, that means two are excluded from the set of people. So it will be C of 9 comma, and but the woman has to invite five of them. So this can be done in C of 9 comma 5 ways. So totally C of 9 comma 4 plus C of 9 comma 4 plus C of 9 comma 5, which is 378 ways in which the invitees can be selected. So coming to the next question, we have got 7 consonants and we are supposed to make a set of 4 different consonants and 3 different vowels. So this can be done. See, 4 different consonants can be selected from 7 consonants in C of 7 comma 4 ways. 7 comma 4 ways. And from the set of 5 vowels, we are supposed to frame 3 different vowels. This can be done in C of 5 comma 3 ways. And we can observe that resulting 7 different letters We have got 7 different letters. That is totally we have got 4 different consonants and 3 different vowels, right? So and these themselves they can be arranged in 7 factorial ways. So the selection of 4 different consonants from 7 different consonants, it can be done in C of 7 comma 4 ways, and the selection of 3 different vowels from the set of 5 vowels can be done in C of 5 comma 3 ways, and the arrangement among these 4 different consonants and 3 different vowels, totally 7, right? It can be done in 7 factorial ways. So therefore we the sets that can be framed are C of 7 comma 5 into C of 5 comma 3 into 7 factorial, which is nothing but 17,64,000. So next question is, there are n married couples who are attending the party, and each person shakes hands with every person other than his or her spouse. So we're supposed to find the number of handshakes. So handshake is possible with 2. So if the number of persons attending the party is 2n, so why I'm considering 2n is both husband and wife. So number of persons attending a party is 2n, and we can say that if there are n pairs, so okay, if there are n pairs of married couples, these 2n persons fall into, if we consider one person, we can he shakes hands with the another person, okay. So every person shakes hands with every other person than his or her spouse. So let's take the number of persons at the party is 2n, and these 2n persons fall into C of 2n comma 2 pairs, right? These 2n persons, they fall into C of 2n comma 2, that is handshakes, 2 handshakes. And here n refers to the pairs which are married couples, because they themselves do not shake hands with their spouse, but rather they shake hands with the other than their spouse. Okay, so 2n comma 2. So 2 pairs, and they shake hands with the other person other than their spouse. So these 2n persons, if you take the number of persons in the party, they shake hands with the each other than their husband and spouse. So if she is a husband, he will shake hand with the other spouse. If he is a spouse, he will shake hand with the other husband. So if this can be done in C of 2n comma 2 pairs, out of which n pairs are married couples. So the number of pairs who are not married couples, this is what we want as a number of handshakes, who are not married couples. So n pairs refers to married couples, and the number of pairs who are not married couples are C of 2n comma 2. 2n refers to total number of persons in the party. C of 2n comma 2 minus n. So this refers to the number of handshakes other than the married couple. So next is, we are supposed to find the diagonals which are there in the regular polygon of n sides. So regular polygon, if you take a regular polygon of, you can refer what is meant by polygon set of lines. See here, a triangle is a polygon, quadrilateral is a polygon, pentagon is a polygon, hexagon is a polygon. Now let's take any polygon, let us take a square. So in the square we can see that there are 4 sides, totally 4 sides, and from this we can have 2 diagonals. We are supposed to find out the diagonals in a regular polygon of n sides. So if you take n is equal to 4, we have got 2 diagonals. So a regular polygon of n sides will have n vertices, right? So if I say regular polygon of 4 sides will have got 4 vertices. So in general, regular polygon of n sides will have got n vertices. And any two vertices, if I take, they determine either a side or it can be a diagonal, right? Any two vertices, they determine a side or a diagonal. So how can we find out the number of sides plus the diagonals? So number of sides plus the diagonals is C of n comma 2. Right? If you take the n is equal to 4, the C of 4 comma 2 is nothing but 6, right? C of 4 comma 2 is 6, and n refers to the number of vertices. So C of 4 comma 2 is 6 minus 4 is 2. So C of n comma 2 minus n refers to the number of diagonals only. So here what you have done, here found out the total number of sides including the diagonal in C of n comma 2, and we subtracted it with the number of vertices, which is denoted by n. So therein we'll get the only the number of diagonals. So in the next question B, uh, if the question is which regular polygon has the same number of diagonals as the sides. That is, we're supposed to equate this to the number of sides, which is given by n. So n of n minus 3 by 2 equals to n. If you do that, we get n square minus 5n equal to 0, wherein n can be since always n, the number of sides is always positive, so n cannot be minus 5, it has to be 5 itself, or n cannot be other value. But from here it is very clear that n can be either 0 or n can be 5. Since n cannot be 0, it has to be greater than 0, that is n refers to the sides, so therefore n value is 5. So we are supposed to find the number or how many distinct 4-digit integers, how many different 4-digit integers are possible with these 6 digits: 1, 3, 3, 7, 7, 8. So okay, though we can have distinct 4-digit integers. Let's take the this is possible by taking two. Let's take 4 integer place. Okay, the first two digits can be identical and the next two digits can be identical. Say for example, we have got C 3377. So we totally have to form 4-digit integers. So that can be the first choice wherein we take the first two digits are identical and next two digits are also identical. In such case, the number of digits or digit integers possible are 4 factorial arrangement of these 4 numbers, and plus the repetition we have to exclude it by 2 factorial into 2 factorial. Okay, how many such combinations are possible is, if you just try to list out each one of them, you can observe the different permutations of these just repetitions. 2 digits identical in the 2 places and 2 digits identical in the next place, or yeah, just by taking the identical digits we can get different numbers, different 4-digit numbers. So how many such combinations are possible? How many such combinations are possible, or how many such arrangements are possible is just 6. So this is the first choice wherein we can frame a distinct 4-digit numbers by taking the first two digits as identical, and that is two of the 4 digits are identical and another two are identical. So next choice is we can frame of distinct 4-digit integers by having 2 digits identical and 2 distinct. Okay, 2 digits identical. Let's say we have got like this. Let's take an example. 2 digits identical. Here 3 is repeated, or it may be 7 can be repeated, or we can take some combination of this and so on. So I can have 1733 also as another pair, and likewise we have got several pairs, but 2 digits are supposed to be identical in the given 4-digit integer set. Okay, how many such digits, 4-digit integers are possible is 4 factorial Okay, we have got arrangement of these four numbers plus two of them will be repeated. So it is 2 factorial into, and remaining two will be distinct. So 1 factorial into 1 factorial. So this can be done in 12 ways. So in this way also we can frame a distinct 4-digit integer. And the other choice is we can have all the 4 digits to be distinct. So if all the digits are distinct, that is if you take 1378, and this can be the only choice wherein all the integers are distinct, 1, 3, 7, 8, and there is only one set. There is one set from which we have to frame the different arrangements, 1, 3, 7, 8, and this can be done in arrangement of these four numbers 1, 3, 7, 8. That can be done in 4 factorial ways by the number of repetitions. Here there is no repetitions. We are taking distinct 1, 3, 7, and 8. So all are 1 factorial, and which is nothing but 24 ways. So totally we can say the number of integers, the total number of permutations which are possible are 6 plus 72 plus 24, which is nothing but 102 ways. So next question is, this is a very important question. We have to find the number of arrangements of all the letters in the word. Here in this word you can observe how many letters are there. This is the main thing, and how many combinations or how many repetitions are there. You can observe that in this in this word Talassi, you can observe that there are the number of letters in this word is 11, out of which A is repeated thrice, L is L, S, and E are repeated twice, and T and H are repeated once. Then, so the number of arrangements or permutations which are possible in this string is basically 11 factorial by 3 factorial, wherein 3 A's are repeated thrice, and H, L, L, S, and E are repeated twice. So 3 characters they are repeated twice, and following T and H they are repeated just once. And so the total number of arrangements are 11 factorial by 3 factorial into 2 factorial into 2 factorial into 2 factorial into 1 factorial into 1 factor, which is nothing but 8,31,600 ways. And next we are supposed to find out the arrangements having no adjacent A's. That is, once we remove the A's, once we exclude the A's, there are 3 A's. So we are going to exclude these A's, and if we remove these 3 A's out of the total 11 letters, so we'll have got 8 letters, and we are supposed to find out the arrangement of these 8 letters, which can be done in 8 factorial ways, and the remaining you can find out the repetitions. Here we have excluded A's now, so that can be done. The number of arrangements can be done in 8 factorial by, so you can observe L, S, and E they are repeated twice. So you we are writing 2 factorial thrice for L, S, and E, and following T and H they are repeated just once. So we have 1 factorial into 1 factorial, which is nothing but 5040. So this 5040 refers to the arrangement in which we have excluded the A's. So now, once we have excluded the A's, we have found out the arrangements of by excluding the A's. Now we can also fit these A's in these locations. You can observe there are how many locations of fitting the A's. These 3 A's are there. We have got 9 locations, and we can fit these 3 A's in these locations. So this refers to having the combination of 3 A's among these 9 locations. This can be done in C of 9, 3 ways. So totally we can do the arrangements having no adjacent A's by 5040 into C of 9, 3, which is nothing but 4,23,360. So this is a task wherein students are supposed to solve the questions. First question is regarding the question paper having 3 portions, and it's done by having a choice of 7 questions for answering. The next question is related to solving the combinations. by applying the formulas and getting the result. Thank you.